Hi everyone, my name is Abdullah Rawi. I'm a machine learning engineer here at Civic. Today we'll be talking about topic modeling and how it's going to be applied to our case. So a quick overview of what topic modeling. So topic modeling basically is a way for computers to find themes or topics in a bunch of documents or a piece of text without humans interference telling it what topics there are in advance. So you can think of it in a simple example of how that could be effective in think about if you have a library of like 1,000 books, an old library of 1,000 books that haven't been read, but we're trying to categorize them into what subject each book falls into, if it's mystery, romance, science fiction, without actually going through like all the books and reading them. A topic modeling does that automatically by looking into like the words that are being used, how much they're being used, the weight of the words, and then based on that, deciding under which subject each book falls into. So why that's helpful for our case, for the like a senator of or office use. So let's say for an office receives thousands of emails a day about different subjects and different matters. So whether it is climate change, policy brief, invitations, rallying, a lot of things. So it will take a lot of time for the office to go through the emails and see what the topic is about and to see what topic is being mostly paid attention right now during the time. So what topic modeling will help them is go scan through all these emails and let them know what the topic of the email without actually having one of the office staff to go through all the emails, which makes it quicker and more efficient for them. So how would the topic modeling help them is the topic modeling will identify the public concerns. So if let's say if we it will go through all the emails and see like in the past week there has been a significant increase of emails about healthcare, that will it will notify the office that we have received this amount of emails in this short period about healthcare, so we should prioritize responding to these emails. Also, it will also provide summaries for quick review. Instead of like manually sorting through each email, the staff will look through topic groups to see what people are talking about. Let's see the meeting of an office, they want to discuss healthcare. So they will just sort to all the healthcare emails they have received in the past month, and that will make it quicker and easier for them. So, how have topic modeling uh, uh, sorry evolved over the years, and while the old methods are being used now, and the future methods. So, old methods are methods that rely on counting how often the words appear in each document using a like a bag of words approach. The best models for that is LDA and NMF. Modern methods are used embeddings and numeral representation of each text to count the weight of each word inside the text to decide if it matters when deciding what topic is being decided. The most two used topic models for that is top2vec and then bare topic. And future models that are coming out right now is LLMs that can either like directly generate the topic via engineering, prompt engineering, or provide like a high refined embedding for clustering. And the most famous one right now is Llama 2. Now we're going to take a look into LDA. What LDA is assumes that each email is a mix of topics, and each topic is a set of words that appears often. So how it works actually, it looks into each document and guesses and that it's made of a possible of mixed topics, and it also guesses which words belong into these topics, and it repeats the process many times, each time making its guesses better and better until figure out which set of words usually go together. So let's say for example, a simple example of that, if you like have a bunch of news articles that are about sports, politics, and cooking. what LDA will do is notice like words like game, team, score appearing together frequently. So it will assume they belong into the same topic, which is sports, for example. And while like words like recipes, ingredients, and cooking appear together in the same multiple times frequently, so it will assume it belongs in the same topic, which is which is like cooking, for example. If you look at the workflow of LDA, what it does is, for our example, is we say we collect emails from the Senate. It takes off it exports these emails in text format, then removes any special characters or like any stop words like the and also private potential private information for security reasons and privacy reasons. Then it creates a word count, which is kind of a bag of words or a term document matrix showing how often each word appear in each email. Then LDA tries to group these words that appear together frequently and like create topics. Then the staff would review the top words in each topic. For example, for healthcare, the top words will be like hospital, funding, doctors, and then they will manually label it as this topic is called healthcare. So any email with these words in it, just uh, put it into the healthcare bag, and then summarize each email belonging to a topic. So to that approach, there's pros and cons. So for pros, it is well-known method, well established, lots of tutorials, lots of tools available for it because it's been there for years. It also produces a list of important words for each document, which could be helpful for us. Cons, though, it doesn't really understand the context beyond simple words, meaning it doesn't look into the meaning of the word. So let's say the word match, it won't detect if it's meant match by like for like sports or match for like a dating app match. It will just detect it as match, and based on that, put it in the same category. And also it requires some tuning, like picking how many topics you want before running the model. The next model we'll look into is an NMF, or non-negative matrix factorization. So this model does, it breaks down large word count matrix into smaller matrices with only positive values, where each factor corresponds to a topic or a set of words. So what it basically does, it turns a document or a text into a big table of numbers, which is of like which word appears in which document. Then it breaks this down into two smaller tables that can show which groups of words go together and which documents focus on these groups. So, for example, for like a simple example of it, imagine you have like a mixed bag of candies, and then you split them into smaller bags based on like their color or tastes. NMF does that by splitting text data into separate piles of the words that appear commonly together, similar to what LDA does. So if we look at the workflow of it, what it does, it cleans the text like LDA does, removing all the special characters and stop words. And then it creates a word matrix that uses rows for like unique words and columns for emails. And then each cell is a word count. Then it factors the matrix into two smaller matrices. W, which stands for word to topic strength, and H, which stands for topic to email strength, and then examines the columns of W to see which words define each topic, and look at the rows of H to see how strong each email belongs to that topic, and then uses the top words in each factor to pick the label for the topic. To that, it also has some pros and cons. So for pros, it is similar to LDA and is simple to use, but it is often faster than LDA, so that's a pro to it. And it's straightforward to implement. Some cons to it, it still only uses basic counts of words and not context meanings similar to LDA. It won't look into the word for its meaning, it will just look into that word. And you also need to pick how many topics you want from the start. So you need to have a preset value for like the topics.
If you're choosing between LDA and NMF, is there any advantage in NMF over any advantage of on sounds like NMF would be better than LDA. Is that accurate, or is there some use case where you'd use, one versus the other if those are your two choices?
They have the similar approach, but because of like how like NMF uses like matrix and everything, it is quicker. So that would be like if it will have like it will give you the results quicker. But they both like use the same method of like looking into like each like grouping the words together and then deciding that's a topic.
Yeah, thanks.
Next up is our topic to vec model, which transforms each email into a vector and represents its meaning, and then automatically clusters similar emails into a topic. So how it works is instead of like counting the words, using embeddings, which are like a numerical codes that capture the meaning of the sentence or the document, and then it groups similar documents together based on these embeddings. Then it finds the topic words by seeing which words best represent each topic. So in simple terms, if you have like thousands of product reviews, for example, what Top2Vec would do, it might group topics like delivery problems, quality complaints, and like customer service complaints, even if the exact same words are always used, because it understands similar meanings, unlike LDA and NMF. So if we look into like the workflow of Top2Vec, it does the cleaning of the text, removing all the special characters and stop words, and then it uses a pre-trained model to turn each email into a vector that captures meaning, and then often applies a UMAP or another method to reduce the vector dimension, and which makes the clustering easier and more accurate. And then using a cluster algorithm like HDP scan to group similar embeddings and finds which word is closest to each cluster center in the embedding space to describe the topic. And then the staff can look into it and label each topic. So it has the pros to it is good at handling short text, like short emails, tweets, brief reviews. Doesn't You don't need to specify how many topics before training the model, unlike LDA and MF. But to cons, it depends on the quality of the embedding model. So if the embedding model you use is not accurate or is not didn't do good embeddings, it will affect the results of the topics. And also it's new. If it's a new topic or like a topic that's unusual, it might not group it correctly. So it needs to, if there's like maybe topics it never heard of or like very special, very niche topics, it might group it incorrectly.
Can I ask, on the previous model,
Mm,
how
yes.
do you think, can you make any comments on the hyperparameters around the clustering? So for example, let's say um, we feel like topics are being joined too frequently when they should be distinct. Any thoughts on how changing different hyperparameters would affect the outputs of the model?
I think maybe. looking into uh having like I think like having a very it's looking into the weights of the words. So it might need to uh have a kind of I say a top like a very broad topics. It cannot it doesn't go into like very specifics. If you know so I'm saying like it doesn't won't be able to like pick into like very niche things or like very specific things. It will have a very broad like presentation of each topic. So for our case, it will be I think it will be hard for it to make a mistake because uh let's say for like healthcare uh rallying stuff like that they don't similar words are not close together if we just take the broader topic of each one.
Yeah.
Next up is BERT topic and specifically modern BERT. Modern BERT uses advanced language models like BERT to create richer and context-aware embeddings and then cluster them into topics. So how they work is they use so it clusters them. What BERT does, it understands the context of each word and then cluster these embeddings into topics and label each topic by checking which word often appears and stands out in that cluster. So for example, if you have like a set of like job application, per topic might group them into a cluster like software development, marketing, or data analysis. Even if the application applicants use slightly different words, uh, BERT embeddings capture like these similarities. So if we look into the workflow, it's similar to Top2 Vector, but uses different models for embeddings and dimension reduction and stuff like that. So what it does is it pre-trains a BERT-like model to get the vectors of each email, then also uses UMAP or any similar method to compress the vectors into fewer dimensions without losing too much meaning, and then uses HTTP scan or any other advanced clustering algorithm to find groups of similar emails, then applies TF-IDF to find a key distinguishing word in each cluster. So that's the difference between it and 2 vector. What BERT topic does, it looks at the weight uses to TF-IDF to look into the weights each word holds into that topic to decide if the email into the email to decide which topic the email belongs to. So it looks into the not all the words into the email, but the words with the most weight. And based on that, it labels each email. So pros to that, it is better at understanding words with like multiple meanings, and often is more accurate finds more accurate topics because it looks into like more details of like words and like how each doesn't look into the like the whole email, looks into like what words actually matter in the email. Cons to it, it is more complex and uses more computing power, and it is harder to set up than the other models, because especially with modern BERT, it is still a new tool, and there's not much documentation on how to use it for topic modeling.
What's the
Okay.
approach to automate the labels you mentioned on that slide?
Automation, like, we could just have it in kind of a separate program. It's not related to BERT. You could just have it in a separate program which takes like each group and looks into the words and then based on that names the topic. If you have like if you know like for example the word doctor would belong to the healthcare model, so it looks into the group and sees oh that group has the word doctor in it, so it should be that's the healthcare group. Or then we have like the let's say think of another topic, like a sports, and you know the word score and match will be in that bag. So you can run it through another program where it looks, okay, this group has these words, so this should be the sports thing, sports topic. But mostly, I think manual staffing, manual like labeling by the staff will be more safer because they will have better understanding of what it is the actual topic belonging to that specific office.
And the related question I have is, in this approach and the approach before, both do not require, in contrast to the other ones, determining the number of labels beforehand, right?
No, no. Yeah, for the first two, LDA and NMF, you need to have a preset number of topics before running the algorithm.
Yep.
But for bird topic and top two vec, it you don't need to preset. It just finds like topics. It does it by itself.
Okay, so you're not visualizing it in like bird topic and topic to vec in like some, and then determining which things go together. It's just it's doing that. That's part of the algorithm. That's part of the output.
Yeah, it looks into like what like the weight and also like how many times it appears into that, and then it reduces the dimensionality so it becomes more and more like accurate.
Okay. So then it basically just determines what the number of topics is most appropriate in that in whatever you're doing, whatever
Yes,
you're putting it through.
yes.
Okay.
An interesting
Yeah.
implication I'm understanding from that is that you can potentially have fine tuning or, a LoRa model trained on the topic itself. Is that correct?
What do you mean? Like, uh, uh,
So in the last step, you're getting a bunch of documents that you want to generate a topic for, and there's a separate model that's usually probably off the shelf
yeah,
that's looking at those documents and then labeling them. Um, which by having it be a separate module, you can, I guess, fine tune on that. So
yes,
if the users particularly, let's say they have a particular preference for how to label that set of documents, then the model can fine tune on their behavior.
yeah. So, like the topic naming could be customizable to the like offices, uh, like what kind of email, what topics they receive based on like the words the bird topic will give it at the end to each group.
Very cool.
I think it probably depends upon how much you want to the how complex you want to use that model to be in terms of latency and optimization. Whether you want it to be like a simple sort of um, keyword identification, or whether you want it to be something as complex as a fine-tuned large language model. Is that what you're thinking, Julian?
Yeah, I mean, it definitely depends on the use case, but for us, we have the benefit oftentimes of not having to worry about latency concerns, which is obviously a challenge some other teams might face. But um, yeah, I think especially in our use case, the more personalization, the better. People like not having to get shoved into other people's boxes.
So our last model and the most advanced one right now is Llama 2, which is an LLM. So it could be asked to directly group emails into topics and produce the embeddings, then cluster it. So how it works, Llama 2 is an LLM. So it's like a big brain model that's trained on tons of text. You can show it the text and ask it through good prompt engineering to find and describe the topics, and it will do that. It's basically asking, kind of asking like a human being, but will do it quicker and more accurate. It can also create the embeddings that can be clustered. So it can do a similar job to BERT topic and top2vec, which it can be better often if you want to like get a group and then like each bag and then customize the topics yourself. So example of that, if you get like a massive like collection of like custom emails, you could just ask Llama, please summarize and then group these emails into main topics, and it would generate a breakdown of like topics of like issues, like billing, technical support, or cancellation. So how it works is after you get your data, clean it up, you can prompt the model, for example, analyze these topics and give me five main topics. That was discussed. Then Llama will use a language model to suggest topics. The model itself, okay, will do the labeling and summarize, explaining what each topic is. And then if for verification, a human staff member could review the model suggested and reprompt Llama 2, or rename some of the topics to uh, fit into their needs. Uh, Prompts to that, it is very flexible. It is very accurate and can do multiple tasks. Not only finding the topic, could summarize and label and do all these steps in only one prompt. But the huge problem of it requires a lot of computing power, and that it's not very useful for our case because it's too powerful for our use case. We don't need a huge LLM to do such a small task, and uh, and if you don't have good prompts, it could generate incorrect results. So that's a huge problem of it. So if we look into the performance comparison between each model, so we're looking into the topic coherence, which refers like how meaningful and logical the topics appear. Context understanding, how well the method handles word context and terms and specific language. Uh, inter Interpretally, how easy it is to understand and label the final topics. And then computation costs, how much power it uses. And scalability, how well each methods handle a very large data sets or new data that's never seen before. So for topic coherence, uh, embed embedding base methods like the top to vec and per topic, and also LLMs like Llama 2 typically have more topic coherent than the pure bag of words methods like LDA and NMF. While for context understanding, they also have better understanding of the meaning of each word. As we said, like LDA and MNF, they look into the word, not the meaning for it. So if a word has two meanings that could belong in two different topics, it will make a mistake of not knowing which topic each that word means, so which topic it belongs to. While top2vec and BERT topic and Llama 2 are better at that. Top2vec and BERT topic are good. They might make some mistakes if it's not clear. While Llama 2, because it looks into a deeper, like it is big brain model, so it's very good at it, so it would not make that mistake. For team, sorry, how easy to understand and labels the final topics. LDA and MF provides a clear word distribution that are straightforward but less context aware to that. While top 2 vec per topic, Llama 2 can generate more uh, exact topics, more context-aware topics that sometimes require extra steps to label properly. For how much power each uses and how quick they are, LDA and MF are relatively fast. NMF is the quickest out of all these models. BERT topic does require more power because of the BERT embeddings. While and top 2 vec is between it is similar to LDA in power consumption. While Llama 2 it requires a lot of power because it is running a huge model to do such a small job. For how good each model handles large data sets or new data, traditional methods like the LDA and MNF do scale well in computing new data, while modern topics like top 2 vec and BERT topics do scale good as well, but embeddings generated it 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 could make some mistakes through the embeddings. And then Llama 2 is very good as well at scaling these large data and new data uh, because it has a better model that's trained on a lot of things.
Doesn't LDA and MF don't you have to rerun that if you add more data to it? But is that because is high scalability because there's low computation costs to
Yeah,
both of those? Is that what you're thinking?
yeah, because of the computation cost. And I think the scalability is looking into like the if you run it like one time on like a already like a pre kind of a data set that you know what's going into it. So that's what's looking into, but also comes into the computation cost of LDNMF. It's way lower compared to like BERT topic and Llama 2, which uses a lot of power.
Yeah, and then I'm thinking about it, the Julian, in terms of your comment, can you go back one slide?
Yes.
You talked about the 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 Llama 2, the negative being that may produce incorrect topics if not prompted correctly. So you talk, the interesting thing about yes, it'd be nice to get things that are more like specialized or customized, but then you have to think about deterministic versus non-deterministic, and that's another factor to think about. Does that make sense, Julian? Wait, once.
Absolutely.
Yeah. Okay. Thanks.
Yeah, prompt.
So the key takeaway is that topic modeling will provide a bird's eye view of large collection of emails. That will be very helpful for our clients or our use case, which they receive thousands of emails a day about different topics. So if they could just have a kind of a dashboard that tells them what each email is about, and also they can sort between each topic, that will help them a lot. There's a lot of methods to use, and different methods fit different resources level and complexity needs. So based on what our need is for that our use case, we should look to make the decision based on that. Modern AI like LLMs like Llama 2 and everything are very powerful, very advanced, and would probably give us the best results. But they are far more powerful than we need them to be and uses far more power than we require. And that's I think a problem now with the huge like interest in AI and everything. I think in years to come, the topic of power consumption by these huge models will be in a huge discussion, especially like how often they are being used and how much power they are using right now. So I think for sustainability and for better use, we should maybe even if they do provide the best and the most powerful models, probably not fitting for our use case for this. It's not sustainable for us. That's it. Any questions, you guys? Thank you.
Thank you. I think very interesting question is thinking about the future of large language models, and are they going to get smaller and more specialized? And also, is the hardware going to adapt and improve? Because right now we're using GPUs that were not designed for large language models. Like, I mean, NVIDIA is like has exploded in terms of its, stock price and all that kind of stuff. But in reality, those GPUs were built for graphics and games, not for LMs. Now they take advantage of the parallel processing, but are there hardware and basically software approaches and even memory approaches that can make things much more efficient and much less cost in terms of both in terms of actual costs and also in terms of compute costs.
Yeah, we saw an example of that with DeepSeek. So, like the different approach from like, DeepSeek than like ChatGPT is, well, ChatGPT is just have like this huge model they trained everything on. What DeepSeek does, it made smaller models and it trained them to be specific things and had like a top level model. Then when asked a question, it decides which model to use and then it sends you to a model. So, for example, like ChatGPT creates the model that can be a doctor, an engineer, or a lawyer, and everything at once. Well, like what DeepSeek did, it made a smaller model that is an engineer, a smaller model is a doctor, a smaller model is a lawyer, and then at the top there's a model that when you ask a question, it decides to send you to which model. So it made like the power uses is way less because you don't have to use this huge model. It literally sends you to a smaller model and then it uses way less power.
And then the other question I think is like, let's say we do get to the point where we have smaller models and we have hardware that's more efficient in terms of these models. Then I think the question shifts, or maybe the memory aspect of it, between different types of memory in terms of hardware. Then the question shifts to deterministic versus non-deterministic, and what and those types of issues depending upon the use case.
Can you explain what you mean by the deterministic or non-deterministic, please?
Yeah, sure. So the LMs, I would say, are non-deterministic, right? It's generative. So you're not and that's why you have hallucinations, right? So you don't have there's a randomness about it, so that you're not um, sort of always sure what you're gonna get, right? And there's a uncertainty about that. Whereas when you have something more like let's say an LDA or an NMF, whatever, right? So then there's more control over what is going to come out. You're not going to end up with, a something that's out of, from left field. It may not be 100% correct, but it's not going to be a hallucination type of effect.
Mm. I get you. Yeah, I think that like goes down to prompt engineering, where like if you get the right prompt and you know that prompt will get you the right result every time, that's all you get to. And there's also the idea of you see, and ChatGPT can create your own GPTs. which have specific tasks. So we could do that where you create a GPT that's specific to topic modeling that will take any text and run it through the same process.
What's nice about BERT topic is it can be repeatable, where you can set seeds for the UMAP, and then the topics that are generated are similar from run to run. So there are other ways that you produce for reproducible results. But definitely I've seen LLMs can be used to provide more nuanced topics. And so sometimes you could do layered approach where you set broad categories and then maybe use an LLM against the broad category to get some, nuance underneath. And maybe on the civic side, one of the things that when I was looking at that dashboard, there are things like education and healthcare and these broad topics that I wouldn't think you would need a topic model for. It seems like an approach there could be just like some type of categorical model that sort of uses some neural net to predict the categories, but then use the topics underneath that in order to support, hey, within education, this is what's trending for this time period. So I was curious, like, how do you actually balance when you use a topic model with just categorization and having a learned model on some of these major topics?
Yeah, those are some really fantastic insights, Aaron. Thanks for sharing. Something that we probably didn't touch on too much is that, topics in our context may often come up on the fly. And, an example is LA wildfires was not a topic that existed 3 months ago, whereas all of a sudden it did exist and is, a really important topic. With the state, just the way news comes out, there's always going to be new topics being generated. The way we have it structured right now, which is absolutely subject to change, is that they're kind of top level topic categories. And to that extent, we can definitely do classification within that. But within the topic, the high level category, so like the economy, there'll be also, new topics being generated
Mhm.
on the fly.
This week is car tariffs, and it
Exactly.
could be, yeah.
Do you have
No,
any
I totally. So
thoughts on
it,
that problem?
no, I was just going to say that your approach makes sense. So you set the high level categories, but then you do topic model underneath to figure out, the nuances underneath.
Exactly.
And that I think that connects to supervised and unsupervised, right? So the Aaron, I think what you're talking about was supervised, so then you need labels and for that versus these approaches are unsupervised.
Jeffrey, going back to
It,
your comment earlier, that's definitely a great insight that, we can develop a model for years and there's still, some percent chance that's greater than zero that the output of the model is going to at some point give something really terrible. What do you think about the follow-up thought that if there's a second model, so let's say we're able to get that error rate down to 0.01%, which is still potentially dangerous, but then you have a follow-up model that is able to um, separately judge outputs, and that has a pretty low error rate as well. And then assuming they're not correlated, which may be an incorrect assumption, would be interested in getting people's thoughts on that. Then then you're dramatically reducing the error rate. And just stacking those might be a efficient way to prevent poor outputs.
I think it probably depends upon like the nature, like you'd want it to be somehow orthogonal in terms of the models because you're basically kind of like using it as like a critique, like as if you're, writing a paper or whatever and you want to critique it and make sure like it's, okay, or I don't know if that's a good, if that's a proper, like a good way of describing it, but um, you'd want the model that you're using to protect against left field type stuff to be I think if I'm not, correct me if I'm wrong, doing a fact check me on this, but different enough from the model that you're using to generate it so that it won't be fooled into the same um, error, right?
That would be the goal. I guess we would Let's get some data, I guess, to back up our hope.
Yeah, I actually joined just because I'm doing a project on topic model and infectious disease right now, and we went through this whole gamut. We did LDA, BERT topic, and an LLM. And so what we're trying to do is sanity check what the LLM comes up with versus some of the other models. And we just had a team discussion on how do we really sanity check the LLM. And, it comes down to labeling data and verification methods in your platform, I think that you could have, users actually verify that to say, is this topic correct or is it miscategorized? And then you can feed that back into the process to say, okay, do better next time because these are off, and then have the users give that feedback. But in our purposes, we're doing like manual verification for a sample, subsample, and then judging error rates that way. So it is an interesting question with some of these more robust LLM-based models. How do you really sanity check it?
Yeah, no, on top of that, Aaron, I think with our problem that we're solving, um, I think we want to err, if we are erring in one direction, I think we want to err on the side of the model being overly specific, because I think a worse outcome for an office is if the model is too generic and putting too many things together, because that is going to be a bigger time waste than if the model is actually generating, like, being too hyper specific and causing staff to have to go in and say, okay, like, maybe we need to put these two together to be more efficient. Um, and so I think that's something, Julian and Nick, that we need to talk about is how are we going to train the model to I guess correct in one direction, hyper specificity over being too generic.
Would there be a way somehow, I don't know if this is, I haven't thought of it, this hasn't popped in my head, but RAG is an interesting approach of making it more like here's your data where you're drawing it from, as opposed to the whole, you know, model. Is there a way that you can envision using that something somehow to like limit um it to a smaller like sort of corpus in some sense?
You mean if you know certain documents are belong in certain clusters, using that to help determine what the other document should be?
Yeah, I guess, yeah. Just in some ways, basically, sort of like instead of because a part of the issue, I think, of the determinism versus non-determinism is basically you have this whole huge model with all this vast information from the internet to choose from, and is it going to choose the right thing or not? Whereas if you limit it, then in a significant way, with like a ragtag approach, then you're limiting that you're sort of defining that space in a more in a way, or that corpus that's drawing from. So yeah, something along those lines possibly.
See what you're saying? It's interesting. Maybe you just invented a new model.
Mhm. I do think if you look at like BERT topic, it basically will assign your topics back to the sentence. So you actually, or like to the sample and the docs, and you can do like for the topic, you can bring up the specific text. So it kind of provides the retrieval for you. And then the LLM can be used on top of that to summarize even further some of the nuances within the topics. Um, and you can just feed the specific text into LLM, say these are our documents that pertain to wildfires. What are some of the key findings, or however you engineer your prompt, right, to tease out some of the nuances. So it'll return, it won't hallucinate in that respect because you're sending them the information.
Yeah. Well, what I'm kind of imagining, Jeffrey, related to what you were saying, is if you do some kind of like contrastive learning, where if you know certain topics or certain documents belong in certain topics, and you would need an enormous data set, I guess, to even compete with the modern models. Um, um, then that would be a way of going about training, I guess. But yep.
Yeah, I mean, you could basically sort of almost think about it like a big prompt, right? That, if you get this, it's, you're giving it training, you're giving it examples, right? And then that's leading it towards what you want it to do. And if you had a thing where basically you were providing, if you had the if there was interest in the consumers, the users of providing feedback on yay or nay, then you could actually set up like, okay, like a start compiling like examples of this is good example, this is bad example, and that will actually, and use that to tip the out, the that would decrease the sort of the left field or right field type or edge case type stuff from happening.
Yeah. Um, any like a single last question before we wrap up? If not, I'll just quickly see if anyone wants to make any asks or offers. I'll note that Civic is growing. We're on the lookout for cloud engineer, people with cloud engineering experience, DevOps experience, security, compliance experience, engineering. So if anyone knows anyone in those fields, definitely let us know, please. Definitely would love to get some more press for John. I think that'd be pretty great. And all the great work we're doing here at Civic. Anyone else want to ask or offer anything?
Did anyone go to the event today? And if they did they like it or not? The Edge AI event.
Jeff, I attempted to, but I wasn't actually able to log in for some
Oh,
reason.
really?
I don't know why. Yeah.
Bummer.
So I'm sorry I missed it, but I'll sort that out for the next one.
Yeah, sure. Sure. No, I just was curious. That's, Um, and I also will see if I can find the link when George gives me the links, I can give it to you so you could view if you wanted to.
Thanks, Jeff. Yeah, that'd
I
be
love
great.
that.
Plan Definitely planning to be at the next one. I just want to say, Abdullah, thank you for putting in the effort to teach us today. This was an insightful presentation for me for sure. And I want to thank everyone else for being here and looking forward to seeing you at the next one.
Abdul, good job, and thank you for answering my questions. I appreciate it.
Thank you
Yeah,
again.
this is great. Thank you so much.
Yeah, thanks a lot.
Thank you for coming.
Yeah, please come to future ones, Aaron. And thanks, guys.
Okay, bye.
All right. Bye.